So I need to let everyone know that even though my presentation was complete 2 weeks ago, the last 2 weeks I've been really sick. I ended up getting diagnosed with COVID, so here I am presenting in quarantine. But I guess this is a good way to do it, given that I can't get any of you sick. So that works out really well. Just to introduce myself, my name's Quentin Alldredge. This project is something that I have never done before. I'm mostly a software GUI front end kind of person and not really a hardware person. So this has been really interesting to do this presentation. So with that, I'll get started here. So first off, a little bit about me. Everyone's feel free to call me Q. I got that nickname from my brothers for the Star Trek reference, but then kept it with my first job because of the James Bond reference, because I made all of the technicians' jobs easier by making the data acquisition easier. I worked for the aerospace and defense industry. First was at ATK, which is now Northrop Grumman, but now I work for Hill Air Force Base. I'm a civil servant with the Air Force, and then I do side consulting under Q Software Innovations. And my little caveat I have to always give is the Air Force did not sponsor or support this presentation. This was all done on my own. There is nothing that overlaps with my work with the Air Force with what I did here. So just have to give that little caveat. So, all right, did I go too fast? Am I doing okay? Did I start too soon?
You're doing okay. Some people are showing their love to you and they're saying thank you for the extra effort to present. Stephen Loftus Mercer was among them, Derek Marito, and Chris Stryker.
Thank you. All right, I'll continue on then. Just wanted to make sure I wasn't going too fast for this system. So here's how to get a hold of me. I've got a new domain name and a new website. It's qsi.dev. There's my LinkedIn. And if you see me on any of the forums, this is my avatar, this LabVIEW Guru. And so that's how you'll know it's me. I guess I ought to switch it to my picture like some of you have, but I kind of like the LabVIEW Guru guy. So I'll keep him there. So a little bit of background. I know some of you aren't familiar with the Harry Potter books by J.K. Rowling, but they're about a wizard that attends the Hogwarts School of Witchcraft and Wizardry, and in the books there are 4 houses that a student gets sorted into. They can be Gryffindor, Slytherin, Hufflepuff, or Ravenclaw, and it depends on different characteristics that the person admires, like bravery or cunning or loyalty or intelligence. And what's kind of funny is each of my family members are all in different houses. So I'm the Ravenclaw, so I'm the one that is for the intelligence, I guess. My wife is the Hufflepuff, and my older daughter is the Gryffindor, and my younger daughter is the Slytherin. So it's kind of cool that we each have a different house, because it makes some of the things like what I did with this clock really fun. So in the Harry Potter books, there's a family called the Weasley family. And the Weasley family is a family of wizards and witches, and they have a magic clock that each member has a hand on this clock. And those hands move depending on where the family member is located. Like in this, it's moving from lost to home. And so you can see that happening. And so this magic clock is what I'm wanting to present about today. So, so there's some examples out there. This first example is from Instructables, is where I got my inspiration. P. Peters created a Weasley clock for him and his wife, I guess, just with 2 hands, but it taught me how to do the MQTT setup, to do the app setup on our phones, and that sort of thing. The other ones in here weren't exactly what I wanted, but just as an example, the Internet of Things location sensing picture frame, her project had photos of each member of the family, and then depending on how far away from home they were, the LEDs next to their picture would be either red for far away or green for close. The Weasley clock in the bottom one, it was a clock, and it had positions for all the different locations, but then it had an LED for each person at each location. So that LED would light up for that person at the location. So it didn't have the hands to light up or to move, just had the LEDs. So my objective is I wanted to recreate the Weasley family clock for my own family. Wanted to give each member their own clock hand that moves based on their location, updates based on the GPS of their phone. I still wanted to keep telling time, mostly because I thought it would be cool to have it look like it had all 7 hands moving at once. Make it look really whimsical, like it's definitely not a normal clock. And then I also wanted to make sure that it still looked like a real working grandfather clock, meaning the pendulum moved and the weights moved and that sort of thing. So, so partly how this system works is it's using MQTT, or message queuing telemetry transport. Now that Instructables article taught me how to get this OwnTracks app. This app is free for iOS and Android, and it has the ability to set up geofences or regions. And so you can name different regions like home, school, whatever your locations you want. And then that article also taught me about this Cloud MQTT. Cloud MQTT is a broker service for MQTT messages. And what it did is you basically set it up as the broker, and then you set up the app to talk to it, and the app will publish to the broker. And the Cloud MQTT was free for up to 5 users, which worked for me because I have 4 members of the family and then the Weasley clock. Then the Weasley clock, my LabVIEW code is set up as a subscriber to this Cloud MQTT and receives those messages, and then I'm able to control the hands accordingly. So I'm going to talk about the materials and then all the different aspects of the design. And then I do have a video of the final product, which I don't know if it's going to work in this environment that well, but I'm going to show it anyway. I did already push it to YouTube, so I'll share that link afterward so that you can see the video without the lag. And then I'm going to show
you. What we can also do, like show it now, but then when we're done, you can give me the link and I can put it directly streaming from YouTube on the stage.
Okay. Okay. Which way is better, to show it or to just give you the link?
Do you want to show the video and then come back?
No, I want to wait till I go through the other aspects. It's got to be the big reveal.
Yeah, then definitely, if you're going to do the video at the end, just give me the link at the end and I'll stream it directly. That way we don't have to deal with the lag. Okay.
Okay, we'll go from there then. All right, so first the materials. I had an old grandfather clock, and it wasn't a real grandfather clock with, mechanical gears and stuff. It had just a basic clock mechanism, with a battery, and then I had another set of batteries that ran the pendulum, and the weights didn't move. They were just chained to hooks on the inside. But I had this clock in it, and it broke and stopped working, and I always wanted to turn it into something. So this is what it got turned into. The other materials, I have a Raspberry Pi with a servo hat. So here's the Raspberry Pi, and then this is what they call a servo hat from Adafruit. And this sits right on top, and there, you can kind of see where I've done my soldering. That's the seat underneath it that sits on the GPIO pins so that it connects. One of the reasons being is the servos use more power. You can't run the servos directly from the Raspberry Pi. It needed to have its own power supply. And I end up using the hat to power all my servos, but really only two of my servos are actually being controlled from the hat. And I'll explain about that in just a little bit. Then I also have 7 Arduino Nanos, one for each clock hand. And I'll explain why I ended up going this route here in a little bit too. Then I've used all of these different types of servos. I actually have a blog post on my website called Selecting Servos. But to do a quick synopsis, basically there are 2 types of servos. One's where you control the speed, and one's where you control the position. And normally, the ones where you control the speed, you can do a continuous rotation, full 360 degrees, but then you don't know the position. The ones that you control the position, you set it between, usually they've got a limited amount of displacement, usually from like -90 to 90 degrees. So I ended up needing something pretty special because I wanted continuous rotation, but still know how to the actual position. So that's where I went with this Parallax 360 high-speed continuous rotation servo. It had a special feedback line with a Hall effect sensor inside, so it kept track of its position too. Then the weights themselves, the weights of the clocks, I control with this 6-turn servo, and it's a position servo, but it has 6 continuous rotations before you basically have to go back the other direction. So, and then I got some buttons for the calibration, which I'll talk about why that was necessary. And then the lights, the WS2812B strip lights, those are fun because they're individually addressable so that you can create all these different special effects like the fire effect that I have going on right now. And then for tools, obviously drills, saws, power sanders. For doing the servo hat, get a soldering iron with temperature control. It helps out a lot. And then probably the biggest thing is my 3D printer. I was originally planning on trying to build this out of wood and use Lego gears and that sort of thing, but it ended up just being really pain to try to figure out how to get everything to fit and to have the gear ratio be what I want it to be and all of that. So after I bought the 3D printer and was able to model my parts using Fusion 360, I was able to create like this part, which is the most elaborate part that holds all of the servos behind the clock face. Here's an example of the gears, mounts for my Arduinos, and then this is the gear that controls the chain for the weights.